Welcome to WB Institution, an online educational app. As today we are going to see about basics of your sensors and transducers. See, this is very sensational topic. It is very important in your measurements and instrumentations when you consider your WE. Okay, this topic is very simple if you understand. Usually when you're reading, you have to relate your reading with the day-to-day life, so that will be very helpful for you to remember for a long time. So in this topic we'll be seeing a lot of examples. We'll see what exactly a transducer is. So if you consider what exactly a transducer is, I'm stating that it is an instrument which is convert a non-electrical quantity into an electrical quantity. So you can see here a non-electrical quantity. What exactly that non-electrical quantity is? It's nothing but your the non-electrical quantities can be your pressure, it can be a temperature, it can be your speed, calculating the speed, it can be your humidity, right? These are the different quantities or parameters for your non-electrical quantities. Okay, see, if you want to see the temperature, it is a physical quantity, that's all. In order to measure that, I need something else, right? So this physical non-electrical quantity, it can also be stated as a physical quantity, fine. This non-electrical quantity is get converted into an electrical one. What is that electrical one? Here it defines the current, it defines your voltage. Okay, these are the different parameters, that electrical parameters. Simply we can state that non-electrical to electrical. Okay, I'm going to convert this non-electrical parameters into electrical measurable parameters. This is what this transducer is used for. Okay, for example, let me state with a real-time example. Okay, imagine that I'm getting fever. Okay, I got fever. Okay, how I will be stating that I got fever? The only thing, as see, if I'm a doctor, I may know what are the biological changes which is happening inside, but as if I'm an engineer, I don't know what is happening inside. Okay, just I know if my temperature rises, I'm getting fever, or if I get a body ache or whatever, that are the symptoms of your fever, right? So if I go to the hospital, what exactly the doctor will do? Whether he will see me and he'll state that you got 90 degrees Celsius, you got 101, your temperature is about 101 or 102. Whether he'll state in that way? No. He'll be using his thermometer. With the help of a thermometer, in that thermometer, he'll measure the temperature, how much I'm having, right? With the help of that only, he'll be stating me, you'll having this kind of, this is your temperature, you're having fever. On, they will decide even physical, the whether I have a fever or not is actually decide upon my thermometer. Okay, what is a thermometer? Actually, it is a physical device. It is a device. See, all have seen a mercury thermometer. In between you'll be having a mercury, it is a mercury filling. These are the readings we'll be having. So if it reacted to a temperature, if it gets react to a temperature, the flow of this mercury will goes up and down depending on this level of mercury. Measuring the temperature, the doctor will state I'm having fever or not. That is what exactly will happen, right? So in that case, temperature is said to be my physical thing, that is non-electrical thing. With the help of something, they have measured that non-electrical thing, right? So this is a basic day-to-day example. If you're relating with as an engineer, as electrical engineer, if you're relating this with the same temperature, in order to measure the temperature of a room, you can measure it, right? So in that also you'll be using an instrument, fine, in order to measure your speed. Okay, in day-to-day life, we are maximum everyone will be having a ride on, right? You'll be having a two-wheeler or a four-wheeler. In that case, you'll be having a speedometer in your bike or a two-wheeler, right? Depending on seeing that speedometer, you will decide at what level you're going, right? So this speedometer is used to measure your speed on which level you're traveling in. Fine. So in order to measure that, we need some instrument. So to measure that, we are using this transducer. Hope you understand clearly about what exactly a transducer is. Clear? In other form, I can state in another definition also. This transducer is used to convert one form of energy to the other form. Okay, I'm stating that is used to convert one form of energy into another form. Let me give you an example. See, in order to make a LED bulb or whatever, a light to glow. Okay, if I on my switch, the light will glow. That is what the normal process, right? If I on my switch, that is a electrical energy. The glowing of light is said to be your optical energy. Am I right? If I on my switch, that is going to be your electrical energy, and the glowing of bulb is said to be your optical energy. In this case, both are energies, right? Both are energy. So here, in this case, the electrical energy is got converted to a optical energy. Am I right? Okay, this is also with the help of a transducer. Fine. Means that they are stating that not only the conversion of electrical energy, it is basic a conversion of energy. Clear? Clear? Hope you all understood what exactly a transducer is. Okay, here we'll find the types of transducer. If you find the types of transducers, you'll be having two different types of transducer. One is said to be your mechanical transducer, another is your electrical transducer. See, in a mechanical transducer, this can be easily stated. See, in order to obtain my output, we'll be having a physical quantity, right? This physical quantity, just imagine I'm going to take a physical quantity. This is going to be my physical quantity, okay? In order to get an output, if this physical quantity is got influenced with any external source, for example, if it is get influenced with the heat, okay, this will result as a mechanical output. Due to this due to the influence of the some external force that will react to it, that will change. As a result, the output will be in the mechanical format. I'll give you a better example, means that bimetallic strip. So the better example is bimetallic strip. Okay, in this what is happening is see, I'm going to take two different types of strips. Okay, this is going to be my, see, this lighter, the thin line is said to be one kind of strip, and this thick line is said to be another kind of strip. Okay, so both are different. These two metals are different. One can be a copper, another can be a metal. Okay, one is a metal and one is said to be a metal, another said to be a copper. Okay, so two metals are got together. When these two metals got influenced with heat, okay, when this got influenced with heat, okay, so basically two metals have their different level of the temperature melting point, right? They have their different level of melting point. Copper will be having different level and your metal will be having different level. When it is got influenced with heat, any one of the metal will get bent. Okay, any one metal get bent. Immediately, if it got influenced with cooling agent, again it will get reflected in the other. It means that this bend will be in the other direction. This will go in the bend will goes in the other direction. Means that this is reacting to the heat mechanically. It is giving the output in the mechanical bending is said to be a mechanical reaction. Okay, this is what exactly a mechanical transducer is. Fine? Fine? Understood. Now coming back to your electrical transducer, simple. The output will be in a electrical format. What is your electrical formats? It can be a voltage or it can be a current in that pattern. Fine. Fine, this is basic difference between your mechanical transducer, means that output will be in a mechanical format. Okay, the electrical transducer, the main point is that the output will be in the electrical format. It can be a current or voltage. Fine. Now, if you consider the electrical transducer, in that we'll be having two different types of transducers. Okay, what are the two different types? Are said to be the active as well as your passive kind of transducers. Okay, So what exactly a active kind of transducer is means that the output, okay, for example, the energy request for generating the output signal are obtained. See, this is going to be a physical quantity, that is your input signal. In order to output, in order to get your output, the energy requires is obtained from this physical quantity itself. In order to produce the output, the supporting energy is obtained from that physical energy, physical quantity itself, means that no external forces get influenced over here. So here I can go with a piezo crystal, electrical crystal. Okay, in this you can see a crystal, okay, piezo electrical crystal. Okay, in this crystal you can see this is a crystal. Okay, two metals, okay, two metals are placed up and down, means that the crystal is placed in between two metals. This is going to be a two metals. Okay, so this is a crystal, this is said to be a crystal. Okay, this is two metals. Okay, so when a external force is applied over it, the crystal will induce a voltage over here. This area, the voltage is got induced when the force is applied over here. Clear? So as a result, where the same physical quantity, the energy has been produced, which will induce a voltage in that particular crystal itself. Fine, there is no external source or energy. Fine. Now, when you consider this a passive kind of transducer, in this, in order to produce your output, okay, in order to produce your output, an external energy source is required. It requires an energy source. Fine? Clear? It requires an energy source. In this area, you can see a word called transduction. What exactly this transduction is nothing but it is used to convert a non-electrical signal into an electrical signal. The transduction word means in order to convert your non-electrical signal into a electrical signal. Fine. So the example of this passive kind of transducer, you can consider potentiometer. Okay, the working of a potentiometer resembles your passive kind of transducer. Fine. Now, if you consider the block diagram of your transducer. Okay, fine. Before I have not spoke about the sensors. In this we have got sensor. Okay, what exactly the sensor will do, ma? It will sense the temperature, heat, whatever, right? It will sense the physical quantity and it is get passed on to the next stages. Okay, it is used for sensing. It is a sensing agent. Sensor is nothing but a sensing agent. Okay, so in this you can see a block diagram of a transducer. So in this block diagram, what are the things you can see? See, you can see a sensor, a signal conditioning unit. This signal conditioning unit can also be said as a transduction. Earlier, in the previous thing, I have told you transduction. Transduction is, what is transduction, ma? Transduction, what is transduction, ma? It is nothing but used to convert your non-electrical signal or a parameter into your electrical parameter, right? So next you can see a digital representation, means that the output, it can be a LCD or any other displays, right? Fine, we'll come back to the first thing. Physical quantity to be sent is, of course, sensor is used to sense your physical quantity. So here the input area, this is your input area. This will sense the physical quantity and then it is given to your signal conditioning unit, whereas in this area the physical quantity is said to be your non-electrical quantity, right? It is a non-electrical quantity. So when it comes over here, right, in the signal conditioning area, the main purpose of your signal conditioning area is to convert your non-electrical into a electrical. So that here the conversion will take place. As a result, the electrical quantity is delivered to your digital representation where you can see the values. It can be your current, it can be the value of your voltage, right? You can understand. Fine. In some cases, in special cases, the entire transducer will perform both the action. means that both the action in the sense, the sensors part and this transduction part. The single transducer will perform in this particular block diagram. You can see a separate blocks, right? It will come to a sensor, then it will go to a transducer. But in some special cases, you can find a single transducer will perform both the actions. Means that a single block will perform both the actions. You can consider the example as thermocouple. Okay, thermocouple. Thermocouple is a sensor which is used to measure the temperature. Okay, it is a sensor which is used to measure a temperature. For example, what exactly a working of a thermocouple is? It's nothing but it contains two different wires, which is got connected together, which is got welded together. This point is said to be both the different wires are got welded together. This is called to be a junction. Okay, this junction point is sensitive. I mean, it acts as a sensor. Okay, this junction point will act as a sensor. Okay, so when this got influenced with a difference of temperature, for example, at first I'm going to treat it with your 20 degrees Celsius temperature. After a few minutes, I'm going to treat it with some 100 degrees Celsius. Okay, both are different temperature. When this come under these two temperature, this will experience a difference of temperature. As a result, it induces a voltage. As a result, the voltage is created. Clear? Means that you can find the sensing action is first carried out. Afterwards, the electrical quantity output they have produced. Fine, this is what I have told. The single particular unit will perform, that is your single transducer will perform both the sensing as well as your transduction part. Fine. So this is what about your transducer as well as your sensing unit. These are the basic concepts regarding your transducer as well as the sensing thing. Hope you understand the basics. If you have any doubts, please write your questions in the comments so that we'll get to know together. Thank you.